Good morning. My topic is on cost crashing project and project management. The contents involved in crashing are normal cost, normal time, cost crashing, and cost time. Crashing of cost and cost flow. What is meant by normal? What is meant by normal cost? And it's the example which I have given. What is meant by normal time? First, we can decide about the normal time. It is the standard time that an estimator is usually allowed for an activity. Hence, the time allowed for the activity. It is the standard time. It is denoted by small t and sets of its time. Next, coming to the normal cost is the direct cost required to complete the activity. Normal time duration is the cost provided directly for the completion of project. And coming to the crash time. Crash time is the minimum possible time in which an activity can be completed by employing extra resources. Means if the time is beyond the activity, then activity cannot be shortened by any amount of increase in resources. And it is denoted by DC. And coming to the crash cost, is the direct cost corresponding to the completion of the activity within the crash time. And now coming to the cost flow, is the direct cost flow as it is the straight line or more than one straight line, depending upon the flatness of the curve. The slope of the straight line is the cost flow. This slope is very helpful in the project cost analysis. Now, the straight lines of the cost of the slope is very helpful for finding the cost analysis in project. And cost flow is defined as the crash cost minus normal cost by normal time minus crash time. CC minus CN by TN minus TC means delta C by delta T. Delta C is the increase in cost and delta T is the decrease in time. Now coming to the example. Here the network path is given. Duration cost of each activity of the project is shown in the figure. The indirect cost of project is 3,000 per week, and we should determine the optimal duration of project and the corresponding minimum cost. And after completing the minimum cost, finding the minimum cost, we should have the timescale versions for each crashing networks. First of all, the critical path is indicated by implies, and the table is given for normal duration, normal cost, and crash duration and crash cost are provided. First of all, we should draw the time networks for the given network, and here it is shown the critical path. We should find the critical path. Critical path is in the direction where activities of 1, 2, 2, 3, and 3. We should add the durations of that each critical path activities means 6 plus 4 plus 5, and the critical path weeks are 15 weeks. And timescale network is drawn in this activity. And now we know that the durations are total duration of this each activities by adding we get as 15 weeks. Now here it is linked to the non-critical activity paths 1 and 3 and 2 and 4. Now the crashing is done by first to critical path and next to non-critical paths by considering the lowest cost. Now we should after finding critical path we should find the cost slopes. For the cost slopes it is found for each activity first. Before finding the cost slope, we should find the normal cost means delta increase in cost and delta decrease in time. Now one of the activities the delta C is given as what is meant by delta C? Normal as I have said the crash cost minus normal cost, like normal time minus crash time. And by finding this we so we will check the first activity. One activity it is given as delta Z means normal crash cost minus normal cost. What is the crash cost for this activities? Means the crash cost 14,500. crash cost minus normal cost. Normal cost is given as 7,000 means 14,500 minus 7,000 will obtain as 7,500. Same as the duration. Second is the normal duration minus crash duration. It is obtained as and cost loop is given by delta c by delta you get as 2,500. Same procedure is repeated for the next activities of 1, 2, 1, 2, 3, 4 and 3, 4. Now normal duration direct cost. Total normal duration is 100 plus 15 minutes and normal duration direct cost is 7,000 plus 4,000. The normal duration provided actually in the problem given table. We should find this normal duration and this normal cost. And total duration is 30 days. Now the crashing started in the 2-3 activity. Why we are considering the 2-3 activities? Means it is the least cost for obtained from all the activities by finding the cost loops of all the activities. So we should consider that part. And 2-3 is a critical path. Means we should crash critical path of 2-3 activity. Activity of 2-3. Now we should crash the activity by 2 weeks. Extra cost of crashing how much? 1,000. We should multiply the weeks during crashing by cost loops of that particular activity. Means 1,000 by 2 equal to 2,000. Next we should find the project duration after crashing that activity by 2 weeks. Means we obtain as 13 weeks. Total project duration of critical path is 15 weeks. So after crashing that activity with respect to weeks, we should substitute the crashing activity weeks from the project duration, which means total project duration weeks are 15 and minus the activities crashed weeks are 2 weeks. 15 minus 2, 13 weeks. And now we should find the total direct cost. Total direct cost we obtain as rupees 30,000 plus, and the crashing cost we have calculated as 2,032,000. Next, calculating the critical activity and non-critical activity paths. 2-3 is critical activity path, 1-3 is non-critical activity path. Means crashing of these activities are crashed by 1 week, and this total activity should not increase by 3 weeks. It's the maximum weeks of crashing. We can crash by 1 week, 2 weeks, 3 weeks, and we should not increase the crashing weeks. Crashing these activities by 1 week each. Extra crashing will get as 2-3 weeks cost loops are 1,000 and 1-3 cost loops cost loops are 1,500. So by crashing at the values of that one means multiply the cost loops with that weeks and add that cost. Next we should find the project duration after crashing. By means 13 minus 1, 12 weeks. Now total direct cost is that 30 at the crashing of previous crashing activity plus cost of that present crashing activity. Means 34,500. Next again the critical activity is calculated. 3, 4. This 3, 4 activity. This calculated is crashing by 1 week. Crashing of the each extra crashing is by 3,000. 3, 4 cost loop is of 3,000 and last one is 3,000. Now project duration 11 weeks. Yes, 12 minus 1, 11. And total direct cost of that project 34,500. The previous total direct cost of activities 2313 and 1. Sorry, and the present extra cost of crashing is 3,000. Now coming to the next activities, and finally we should crash the activities and now crashed for 1-3 and 1-2. 1-3 is the non-critical activities and 1-2 is the critical activity. 1-2 is the critical activities and 1-3 is the non-critical activities. And they and now they we should crash by 2 weeks. Means we should calculate, we should multiply the cost loads of that two activities by 2 weeks. We'll get the amount of 8,000 and the duration is of 9 weeks, 11 minus 2. And we should add this crashing cost to previous crashed activity total direct cost of project. And now all the three parts have become critical. Means one and all the three parts are 1 3 1 3 2 3 and 1 2 2 4 3 4. Now we should finally crash with 3 4 and 2 4 activities. This 3 4 and 2 4 have been now crashed. 1 2 2 3 and 1 3 have been crashed. Now we should crash for 2 4 and 3 4. 2 3 and 3 4. 2 4 sorry 2 4 and 3 4. 2 4 and 3. Now same we should multiply the activities by 1 week and cost of that activity is fine and next durations of that activity is calculated and total direct cost is added by the crashing cost of that activity and previous cost of the crashed activity. Now the one critical path is fully crashed and further crashing is not possible. Now the timescale networks of the each crashing activities have been drawn. First, this is the original time network which we have drawn from before starting of the problem. And now for coming to the stage 1, we have calculated for the 30 minutes means crashing of 1 3 crashing of these activities 2 3 activities by 2 weeks. So 1 2 3 4 and now 6 to 1. By adding we'll get 30 minutes. In this way the total crashing of activities we should draw the time networks. And finally we should calculate the total cost of the project. Now the project durations are given as 15, 13, 12, 11, 9, 8 and direct costs of the projects are represented there. And now direct costs are nothing but the cost we have calculated for this crashing activities. Now 30,000, 32,000 for 15 weeks. Like that we should denote in a table. In table. Now indirect cost is applied by multiplying the direct cost. Means it is given as 3,000 per week. Now we should multiply the each direct cost activities and we should write it here. And now we should add this both direct cost and indirect cost. It is the total cost. And the optimum we can see here as 12 weeks and 11th week. So we should so I will consider the minimum week as 11th week optimum weeks and the least cost is 70,500. In this way we should continue the crashings of project. The usefulness of this crashing the project is we can reduce the time and we can reduce the weeks and costing limits by using the resources and we can complete the work in specified time or in least time. Thank you.